Good morning, students. Good morning. One of my favorite days, factoring and fractions. You're allowed to use two F words today, fractions and factoring, and let's just throw in the third, fun. Oh, quit your belly aching. It's not that bad. Let's get going. Let's just rock and roll. By the way, my name is Mr. Krause. I am the worse half of a better half of group of teachers. My partner in crime is Miss Newman. Newman. My last name is Krause, and we are nkinfinity.com. All these videos can be found over at our website. Not sure if I've been there in a while. There's my email to myself. Let's go there. There's my partner in crime, Miss Newman. Come on, come up, computer. Going slow this morning. Just updated it. There's my partner in crime, Miss Newman. We will probably have this under construction site down soon. Oh my gosh, I'm still working on it. But if you go over here to New York State Teachers, students, I'll have some stuff there for you. I'm ready for you. I'm ready. I'm not forgotten you. But for right now, if you want to go to New York State Teachers and Algebra 2 lessons, all of these lessons can be found on here. Now, we're working on Lesson 5. Notice what happens when I click on Lesson 5. Nothing. But if you click on 4, you go down to all the 4 videos. And 6 is done. But somehow we've forgotten 5. No, we're just getting to 5 now. By the time you get here, 5 will be available to you. So all of the videos and what each one of them does will be available to you. So that's a great resource for you. By the way, if you want a copy of this calculator, you can just go to TI Inspire videos. By the way, right now I've only got, 15 or so up here. I'm working on those. But you can also, it shows you how you can rent it. And what you would get is this calculator right here, the TI Inspire student calculator. Or you can buy it from Amazon. I think at Amazon right now it's about $120. Don't balk at that price. You spend more on your clothing for your sports or your athletics or your costumes for whatever thing you're in. So to buy a computer that's going to last 6 years, just tell your parents, yo, Mom, seriously? Dad, it's going to last me like 6 years. Anyway, for the next... well, whatever. My name is Mr. Key. By the way, if you can't afford it, but maybe you can afford that $27.50 a year. But remember that it does not work on a Chromebook. You have to be able to install it. Although I just met with the TI people yesterday and gave them a piece of our mind that they should have a Chromebook plug-in that we can be able to use it on our Chromebooks. But not sure how that's going to work. Anyway, let's just rock and roll because we've got some fun ahead of us. Fractions and factoring. I'm so excited. All right, so let's see. I think we did this yesterday, right? Well, maybe not. Let's just take out the GCF. GCF, greatest common factor. If I look at the numerator, remember that's a binomial. We're going to wrap it in parentheses like wedding rings, man. You wrap the wedding rings around it. They're a married couple. You can't break up the married couple. Yes, I know there's lots of divorce today. I apologize for that. But we are not going to break up that wedding couple. So I can take out a 9x to the 4th, 9x to the 4th, and I'm left with, wait a second, I took out that whole thing. You can't take out the whole thing and just leave nothing, right? There's still a minus sign. I still have to have a minus sign. So what goes in the front? Nice job, Bob. See, I switched from Bob to John to Bob. 1, because 9x to the 4th times 1 gives me back my 9x to the 4th. And let's see, what would that be, 3x squared? Yeah, I think so. And then I take 3x to the cubed on the bottom to the cubed. Ooh, that's some good English there, Krause. All right, 3 goes into 9 3 times. I can get rid of all 3 of those, and 3 of those leaves me 1. So my answer is x, 1 minus 3x squared. Where is choice 4? Oh, why don't I have 3 choices? By the way, it's 3x, 1 minus 3x squared. But I'm still missing choice 4. I don't know. Is this the answer? Oh, no, wait, that's not the answer. Oh, my gosh. I'm so... oh, yeah, now I'm in better shape. This is the answer, clearly. All right, kids. Clearly, this is going to be a long presentation. Let's just keep the mistake-o-meter going. There's the mistake-o-meter. Mistake-o-meter. 1 year in algebra, we actually put up a sign called the mistake-o-meter. We had a lot of fun with it. At least the kids did. Jerks. They just kept putting tick marks up. There's the mistake-o-meter. We got 1. Let's go. That's the only one you're getting today because I've had my Dunkin' Donuts coffee and I don't even make any mistakes after that. Married. Let's factor. Numerator, I can take out a 25. I'm left with x minus 5. Clearly, we've got some dots in the denominator. Dots in the denominator. Who knew math could be so much fun? I did. Oh my gosh. Maybe I had too much coffee. Dots, difference of two squares. X plus 5, x minus 5. And I just take out this. Let's take out this one. Wham! Wajam! And I'm left with 25 over x plus 5. It's got to be one of those answers. Choice 4. All right, get rid of the black pen. I can't see it. All right. Whoa, 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 whoa. Rational expressions are fractions. Oh my gosh. Which is the same, really, as division. So when you think of fractions, you're really thinking of division. So multiplying rational expressions is, and I really want to highlight this word, it's easy. Now, some of you want to say, yeah, I got another F word for you, Krause, and it ain't fun. Fractions are not easy, and rational expressions are not easy. But we're going to break it down to 3 steps. Factor. Now that's the hard part. Factoring really is the hard part. Cancel. Another mathematical term for this is dividing out the common factors. But in your mind, we'll just say cancel. And then rewrite the answer. 3 steps, kids. It ain't like I'm asking you to do like rocket science or anything. Some of you are like, yeah, you are. So, let me start with an easy one. We skipped the factor one because there's no factoring here, and I just divide out the common factors. 3 goes into 15 5 times. 4 goes into 14 twice, and I just have to rewrite it. Oh, wait a second. The whole numerator's gone again. Oh my God, Mr. Krause. So you might want to get in the good habit of doing this. 7 goes into itself once. 7 goes into 14 twice. 3 goes into itself once. 3 goes into 15 5 times. Because then you don't do things stupid like go, oh man, the answer's just 10 because there's no numerator anymore. No! Numerator is 1 times 1 or 1. The denominator is 2 times 5, which is 10. 1/10. There's a big difference between 1/10 and 10. Would you rather have $10 or 10 cents? That's the difference. So how many of y'all, because you did a little bit of this in algebra, but we're going to make it a little bit more difficult. How many of y'all, when you saw this in algebra, just started going like, fractions, factoring, I'm scared. I'll be back, and we'll make it easy. When I'm about to make fractions and factoring easy for my students, I drink from the nectar of Dunkin' Donuts coffee. It helps me help them. I know what you're thinking. How could I not be on TV? With commercials like that, I don't know if you've seen my other videos, but with commercials like that, how am I not a spokesman for Dunkin' Donuts? Really? How am not? I don't know. Anyway, let's factor. Let's do this. So, I like to take the easiest ones first. You don't have to do them in order. Nothing says you have to do things in order. This one's probably the easiest. I just have to take out GCF. The GCF is 3x. Let's see. I take a 3 out. I take an x out. I'm left with x. I take a 3 out. I take an x out. Excuse me. And I'm left with plus 5. The bottom, this denominator's just as a GCF. We'll take out 6x. Ooh, that's not bad. 6x. By the way, this is done much easier if you do it in colors. Okay? You'll see in a minute why. And colors make math fun. Just kidding. Yeah, that was good. That was funny. I'm going to wait till this one lasts, because this one actually I want to have a little conversation about. So let's do this one. X and x. They got to multiply to 6, negative 6, and add up to negative 1. Well, hopefully by now you know that's negative 3 and positive 2. So this one here, do you realize that it's backwards? As soon as we're done with this problem, alerts are going to go through your head afterwards. I'm going to teach you a new rule. But you notice it's backwards, correct? So we got to maintain that backwardness. That's a math term, backwardness. The 4 comes first. Now, I'm not used to always seeing the 4 first. Normally we see the x first. But in this case, the 4 came first and the x squared came second. Now we have dots, difference of 2 squares. But we have to take care of the 4 first. We're going to put the 2 and 2 here. Why did all of a sudden that just slip down like that? That is weird. I didn't draw those there. Let's do this. And then go, no, still there. I don't know what happened. That's weird. I'm going to have to back the video up and see. Watch those things pop down. They had to. I didn't put them there. All right. Now to get the x squared. I'm like a bad kid, man. I'm like a spastic. Bloop, look, let's go there. Bloop, bloop. How about that movie? Squirrel. Squirrel. Anyway, let's get x squared. So we're going to put x. And just like before with normal dots, 1's plus, 1's minus. So we've taken care of the factor. Now we got to divide out the common factors, otherwise known in simplest terms is factoring. Let's grab orange. Let's see. By the way, I don't know why there's an equal sign here. That's again something weird going on. Oh, let's just disappear. All right. So I have okay, wait a second here. I have an 2 plus x and an x plus 2. Let's see. Oh, wait a second. I have a 3 that goes into 6 twice. And this x can cancel. See how easy it is to cancel things out when you have different colors? Okay, so now I'm going to highlight something. I'm going to highlight this and this. And we're going to talk about those things over here, because I really want to make sure you understand this. This is 2 minus x on top and x minus 2 on bottom, or in the denominator. Well, if I wanted to rewrite the numerator so it was quote-unquote normal, what I would do is I'd say, okay, I'm going to factor out a -1. I'm going to take out a -1. So I'm going to put that -1 out front. And when I do that, then the 2 becomes negative, and the negative x becomes positive. Now you're thinking, why would anybody ever want to do that? Okay, follow along. Let's make sure that that makes sense to you. -1 times -2, that's positive 2. And -1 times positive x, that's negative x. So I haven't changed the equality of what I have here, have I? You're right, I haven't. So why would I want to do that? Well, let's rewrite this slightly differently. This is -1. By the way, you'll never have to do this again. And I don't like the way this is written, so I'm going to put the x first. So it's positive x, and it's -2. All over x minus 2. Well, lo and behold, those cancel, and I'm left with -1. So we've got a new rule. I call it the -1 rule. I'm going to put it in quotes because it's not official. It's the -1 rule. If you are given x minus a over a minus x, or whatever it is, they're exactly the same. This is only true with subtraction. I'll show you why in a second. If you have this, and it's only true with subtraction, they're exactly the same, but backwards, it's equal to -1. So I don't have to go through all this crazy rigmarole crazy stuff to figure out that anytime I have something over itself, it's -1. Because I can do this with anything. I can do 27.2 minus x all over x minus 27.2. Take out the -1 in the numerator. Now I'm going to switch their order right away. So because this becomes positive x, and this becomes -27.2 all over x minus 27.2, and they cancel. So it doesn't matter what you have. As long as they're backwards and they're exactly the same, then I can say these two cancel, but they make -1. And what you want to do is put a big -1 out front so you know that it's there. I think we're done canceling common factors out. So what you want to do now is just kind of roll along the top. That's why it's, if you find it doing pen, it's good. I got this -1 here, and I got this x minus, or x plus 5 here. So negative x plus 5. I don't need to put 1 there. All over, now look, let's look. This wasn't canceled, and I got a 2 here. So all over 2 x minus 3. There's your answer. I have a riddle for you. Why does it always look so easy in math class? Because I'm a math teacher. Oh my God. What up? That's good. You can use it. Go ahead. You're free to use it. Yeah. You don't even have to tell people that you got it from me. You just like, oh man, that joke is, that riddle's awesome. All right, let's go. We got a factor. I hate the orange pen, but we're going to use it for now because we got to start it with it. We're going to factor, and then we're going to divide out common factors, and we're going to simplify, rewrite it. All right. I'm going to start with the easiest one. I don't know if you noticed, but this is probably the easiest one, 4x. And then the rest of them are all a toss-up. Out of this one, I'm going to put my wedding bands around everybody and say, oh, look at them all. They're all married. Okay, there's 3 there, so I'm not even going to talk about what that is, but they're married. They're married with kids. Can't break them up. Married with kids. That's what I'm going with. All right, in the numerator, we're going to take out a 4x. Now, remember, you can't take everything out. So if I take that 4x out, I still got a minus here. I got to fill the spot. I took the 4 out. I took an x out. I know this is an x, but when you take everything out, you take out and you leave a 1. Because when you distribute it back, 4x times 1, 4x. Got to be able to do that, okay? In the denominator, there's only one way to multiply to 3. I mean, I know there's an infinite way to multiply by 3 to 3. But for us, we're going to say there's, oh, you don't think so? What's 81 times 127? 3. Bam. You don't believe me? Go check it on your calculator. All right, so, oh, wait, it's negative 3. So 1's got to be plus, 1's got to be minus, and they got to add up to positive 2. So that's positive 3 and negative 1. Okay, no problem. Over here. All right. They got to multiply to negative 6. So that means one's got to be positive, one's got to be negative, and they got to add up to positive 1. So that's 3 and minus 1. That makes sense? Is that right? No, that's not right. I even had to check my own notes because I'm like, what the heck? That didn't make any sense. Mistake-o-meter. Remember how I said math makes it easy even for math teachers? No, it's not easy for anybody. Nobody likes math. Just kidding. Minus 2, right? Because positive 3 times negative 2 is negative 6, and they add up to positive 1. All right, take out my different colored pen. We'll go with purple. We'll start canceling stuff out. This 4 goes into itself once, goes into 4 once. This x, see ya, wouldn't want to be ya. All right, anything else? Oh, the x plus 3 is canceled. Notice how using a different color pen is so nice. Now, here we go. 1 minus x. X minus 1. Now, I should have known right away at the beginning. Notice how the x squared was second here, and the x was first, and it's sort of backwards. As soon as you start to recognize those things, you know you're going to have the negative 1 rule in there. So, yes, I can cancel these, but I have to put a negative 1 in the numerator. All right, let's run across the top. What have I not canceled on the top? Negative 1, 1, and x minus 2. So that's negative x minus 2. And the denominator, nothing, and 1. But I don't need a 1, so hey, kids, there's your answer. Woo! Oh, hey now, no factoring. Yay. I always get a problem like this. A kid goes, well, I don't even know what to do with that. What are you going to do with that? You can't even factor. You don't even know. I'm like, you don't have to factor. You just start crossing stuff off. Let's see. 2 goes into 8 4 times. It goes into itself once. 4 and 4 cancel. This y cancels with one of these. Oh, wait, hold on. Let's make it easier. That y cancels with that y. These two y's cancels with 2 of these, leaves me just 1, so I just leave that one there. And this 1x cancels with one of these and leaves me 2. Okay, let's run across the top. I've got x squared, 7, x to the 4th, and y. So I'm going to get 7. Let's see, x to the 4th and x squared, that makes x to the 6th. Remember, we add the exponents, y. All over, gone. All over 1, but I don't need to put over 1. There it is. Yay. Oh, what am I doing? I'm not done yet. Do you see what I see? Do you see what I see? A squared term after a regular term that just tells me I'm gonna have a -1 rule. This right here is gonna tell me, because I have squared after a regular x, there's a really good, don't put a -1 in there now, but there's a really good chance later on we're going to have the -1 rule. By the way, that singing was probably my best singing ever. So if it made your ears bleed, I apologize, but I'm actually pretty impressed with myself. Do you see what I see? All right, so let's start with the easy one. 3x. Boom. Gone. All right, let's take care of this one right now. We can take out a 3x. Remember, if you take everything out, not everything's gone. We still got a minus. 1. Take out a 3, take out a square x, 1 minus x. I said 1 minus x again. I think we just did a problem like this. X, let's go plus 5 minus 1. What do you say? What do you say, right? Multiply to -5, add up to +4. X and x, because it's -20, they got to be plus and minus. Because the middle term is 1, I mean, get in the habit of this. The middle term is 1. That means the two numbers have to be next to each other. And the bigger one's positive, so 5 and 4. All right. Now let's take out the green. Oh, it's so festive. I'm going to take out this -1 rule right away. Gone and gone, so I don't screw it up. And I'm going to put a -1 out front. All right. This 3x divides evenly into that 3x. This x plus 5 divides into the x. It's like the last problem. -x minus 4. Done! Do you see what I see? So the squared term, the x is negative, the x is backwards right here, boom, -1 rule right there. There she is. Do you see it again? Anyplace else? Squared's first, the bigger term is first, so that's where we're going to have that -1 rule issue again, okay? So let's just not worry about it. We'll take care of it right away. So that's dots, but it's backwards. Leave it backwards. Don't try to turn it around thinking, oh, the x squared sperm should have gone first, so I'm going to put it first because that's the way it should be. Putting your finger down. No. It's not. You do it the way it's there. Plus x, minus x. Don't start changing things around thinking you're all that in a bag of cornflakes. Where did cornflakes come from? I don't know. That's the only thing that came to my mind. In the denominator, look at that married couple. Married with kids, married couple, can't break them up, but you can take out a GCF. So I can take out a 2x squared, and I'm left with, take the 2 out, take squared out, I'm left with x minus 3. Over here I can take out a 4x. Don't forget, if you take everything out, you don't take everything out, there's still a minus. Don't make me mad, I'll jump through that monitor. Start hurting nobody at all, because I can't jump through a monitor. I might hurt myself, though. And then the denominator here, I think we've already factored this before. It's x and x. There's only one way to multiply to 3 and 1. And the larger one has to be positive. Positive 3 and -1. All right. Take out the red pen because we're still staying with the Christmas theme. Even though you're probably doing this unit after Christmas. Maybe it's around Christmas. Maybe you're still in the Christmas spirit. I don't know. Let's take care of the -1 rule right away. 3 minus x minus 3. Put it out front. Let's take care of it. Now notice x plus 3 and 3 plus x cancel right away. Now why is that? You've got x plus 3 and 3 plus x. I don't care where they put them. The reason it is because addition is commutative, which just means I don't need to write it like that. I can rewrite it like this. Now that's true with addition and multiplication. They have that commutative property which allows me to switch their order without changing its value. Subtraction does not. That's why we have to take care of it slightly different. Okay. The x minus 1s cancel. Oh my God, everything's canceling on this one. This 2 cancels and goes into 4 twice. Goes into itself once. Let's see. This x cancels with one of these x's. Now, your goal now is to look through and see if you can find all the things that didn't get canceled. -1. Maybe I'll take a highlighter out. -1, 2, 1. X. Oh, that's it. Okay. So that's where I got everything. So in the numerator, I have -2. Because remember, you're multiplying. -2 all over x. 1x if you want, but over x. There it is. Oh, man, oh, man, oh, man. Here we go. Dividing rational expressions is as easy Why did I write, oh, is also easy. I thought that was as so easy. Is also easy, just one extra step. Now, we got to do, I hate to do this to you. I know some of you can't handle this, but we have to do it. We have to take a trip back to 5th grade. So, you ready? Wayne's World? Oh, come on. Wayne's World? Oh, I'm so old. That's us going back into time. If you remember correctly, when you were in like 5th grade, they taught you. Now, they probably taught you some crazy method, but what you ended up learning was that when you divide fractions, it's just the reciprocal operation of multiplication. So what we're going to do is we're going to take 12/5, and that one extra step is to flip. You'll notice these three are the same, but we have that one extra step of flipping. So the only one that gets flipped and it becomes a multiplication problem is the one, anything that follows a division symbol. So that one's going to get flipped to 25/6. Once you've done that, then it's the same as before. 5 goes into 25 5 times, 6 goes into 12 twice, and I end up with 10 as my answer. So let's just get going. Algebraic, divide the two fractions and write your answer in simplest form. Okay. First things first, I'm going to try to take care of both things at the same time here. Okay? So I know I'm going to flip it. So what I'm going to do is I'm going to say, okay, this times this, and I'm going to take care of the one I need to flip first, just because I want to make sure I say, okay, I'm going to deal with that one first so I don't make a dumb mistake. So I got to flip it. Sometimes I write myself a little note. Hey, this one needs to be flipped. Put the 14 on top. Now this x squared minus 4 is just dots, difference of two squares. So we're going to factor it, x plus 2, x minus 2. And then the rest of it I just have to write down normal. Don't flip it. The only one that follows the division symbol gets flipped. Don't forget that. Oh, I'm talking to you. Over 7x. And we'll take out a different colored pen. Let's see what pen. Blue. We haven't used a thicker blue one. So let's see. 7 goes into 14 twice. It goes into itself once. X plus 2 cancels with x plus 2. So in the numerator, I have 2. And in the denominator, I have 1x, x minus 2. Now, so I don't really need that x. The ones are only necessary if everything goes away. Other than that, you really don't need them because multiplying by 1 is just kind of boring. There it is. What do you think, kids? Oh, my God. All right, moving on. I'm going to take care of the division first. You're going to get so good at these, you're going to be like seeing these problems, you're like, woohoo! Fractions! Factoring! Fun! Woo! All the F words you're allowed to say in math class. Oh, don't use those other ones. You get in trouble with those. You know what I'm talking about. Fiction, non-fiction. Ooh. Ugh, I don't even want to talk about those. Anyway, let's flip this one. This one's going to come on top, and we're going to factor it. So let's see. It's positive 30. So that positive tells me the signs have to be the same. And this one tells me they both have to be negative. So two numbers that multiply to 30 that add up to negative 11. 5 and 6. This one just has a GCF, but it goes in the denominator. In the denominator. I just like saying that because it sounds really cool. Oh, it sounds cool. You don't even know cool. All right, and then I take out a 2, and I'm left with x minus 5. All right, that's it. Let's lock them out. Gone. This x cancels one of these x's. I'm left with 7 over 2. That's it? Seriously? All that work for 7 over 2? All right, moving on. By the way, you should be trying some of these on your own. I'll give you a hint on this one, and then I want you to pause it. Okay? The hint on this one is, first of all, this is a married couple. And if it's not a fraction, you have to make it a fraction by doing it over 1. All right, so hit the pause button right now. No, right now. Seriously, hit the... Oh, you did? Oh, you're back. Oh, sorry. Okay, let's turn it... Sorry, stop. You people, you're starting to make me mad. We're going to turn it into a multiplication problem. Married with children. All right. Oh, this one. Now this one, because I'm doing this for two different teachers, I got to do this slightly different. But we're going to take care of this one first. The one's going to go on top, and I can take out a GCF of x, and I'm left with 3x plus 5. Now, normally this factoring on this one, by the way, the denominator is just 4x squared. Normally the factoring on this one would be very difficult. In fact, I'm going to do it over here real quick for you. And then I'm going to show you how to cheat because, quite frankly, if you're not cheating in math class, oh no, hold on. If you cheat in math, no, never, what am I talking about? So I'm going to do this my way, and then I'm going to do it the other way. But that's okay. They're both good. So I call one of the ways Newman and one of the ways Krause. We'll do Newman first. So what I'm going to do is I'm going to rewrite this out. Now 6 times 15 is 90, but it's negative 90. So I need to multiply to negative 90 that adds up to positive 1. That's pretty easy. Whenever the middle term is 1, you know the numbers are going to be right next to each other. Negative 9 and 10. So minus 9x plus 10x minus 15. Group. Take out a 3x. I'm left with 2x minus 3 plus. Take out a 5. I'm left with 2x minus 3. So my two factors are 2x minus 3 and 3x plus 5. Now let's pretend like I don't see that. I'm going to rewrite it over here. 6x squared plus x minus 15. If you're a factoring genius, you can just skip this. I'm just going to go right into two sets of parentheses. Now, I am relatively certain it's going to be 3x and 2x. I just am pretty much sure. And since this is 15, there's really only two ways to multiply 15, 3 and 5 or 5 and 3. So let's just put them in there. Oh, wait a second. I cannot put a 3 with this 3 because then it would have a GCF. And there was no GCF in the original problem, so I cannot put the 3 there. So the 3 would have to go here, and the 5 would have to go there. It doesn't have a choice. Unless it's 15 and 1. All right, let's see. This would make 9, and this would make 10. I need to make sure the 10 is positive, so that's positive, that's negative, and we're done. Do we get the same answer? Yay! So let me show you how to cheat, though. Those are the answers, those are the factors, they come over here. But let me show you how to cheat. Do you see how we have a 3x plus 5 here? There's a really good chance there's going to be a 3x plus 5 there. I just say, okay, there's a 3x plus 5 there. More than likely, going to be a 3x plus 5 up there. All right, then I say, okay, what number 3x by gives me 6x squared? 2x. What number do I have to multiply 5 by to get negative 15? Oh, negative 3. And that's how you cheat. Okay, now that we've factored, let's just start lopping stuff off. 3x plus 5, 3x plus 5. Is that it? All that work for that? All right, 2x minus 3 in the married couple. Don't forget about that. And then 4x, did you forget about this one? Cubed. Ka-ching. Ah! Ooh, 3 fractions. Oh my God. Seriously? Did you just whine? Enough of that. Every time I come back from a break. So all we're going to do is go cha-ching, cha-ching. We're going to cheat, and we're going to work on the easy ones first. I'm going to work actually on this one first. Uh-oh, alert, alert, alert. Backwards, backwards, backwards. That's going to be the negative 1 rule. Do you see it? The squared term is second and the x is first. Be aware of it. Notice when you see it, you're probably going to have the negative. It doesn't always happen, but there's a really good chance. There's a really good chance you're always going to have the negative 1 rule. Okay. That one's going to go on top because remember, this one's being divided, so we're going to do that one right away. I can take out an 8x, and I'm left with 2 minus x. Okay. That one's done. I'm going to take care of this one right away, too, because it's not too bad. X and x. Easiest way to multiply to 28 is 7 and 4. And I want to end up with a positive sum, so we'll make the 7 positive, and we'll make the 4 negative. Done. This one's next because it's the next easiest. X plus 4, x minus 4. This one's the next easiest. Take out a 2x. X plus 2. Have I made any mistakes yet? Do I need to go to the mistake-o-meter? And then these middle ones aren't too bad. Multiply to 14. Add up to 9. That should be pretty easy. 7 and 2. Both positive because this is positive and this is positive. This one's going to have one positive, one negative. But that's not too bad. We're going to do x and x, 4 and 2. And I need to come up with positive 2. So I need to make sure that that's positive and that's negative. All right, now that you've done all that, let's go green again so we can get like Christmassy again. Let's start crossing stuff off. Where's my -1 rule? Here it is right here. X minus 2, 2 minus x, and let's put that -1 up there. Don't forget about it. All right, x plus 2, x plus 2, x plus 4, x plus 4, x minus 4, x minus 4. X plus 7, x plus 7. Holy crap. This 2 goes into itself once. This 2 goes into 8 4 times. This x cancels with this x. So if I look all across the top, all I see is a -1 times 4. -4. And the denominator, all I have is 1. All I have is 1, 1, yeah. Oh, okay, whatever. All right. Long division again, yay! So don't forget, we're going to divide, we're going to multiply, subtract, bring down. If you get to something you don't know how to factor, then we can, oh, sorry. We are not 8 years old, so we don't write remainder 4. We write this much is left out of this total, aka remainder over divisor. That was my part. That's a Newmanism right there. That's like perfectly say, we're not in 8th grade anymore, so we don't write remainder 4. Do you know what? Oh, you used to write remainder 4. It's not like you when you used to go, okay, 3 goes into 14. Let's go. It's going to go in there 4 times 12, and so it goes in 4, remainder 2. Okay, that crap we don't do. It's really, the answer would be 4 plus 2/3. Because it's a positive 2/3. So you're going to see how we're going to do this right now, kids. So we're going to divide. See, the reason I need to divide is because I don't think I know how to factor that. I'm not really sure how to factor that. In fact, I don't think it's factorable. In fact, it's not. If you tried to factor that thing, you would not be successful. So what we need to do is do long division. Oh my God, long division. This is the best lesson ever. Long division and factoring and fractions and the -1 rule. I'm going to tell you right now, so far, this is probably one of my favorite ones. I'm not lying. You think I'm lying? I ain't lying. I ain't lying. Let's do it. X times 2x is 2x squared, so 2x squared. 2x times 6 is plus 12x. We're going to subtract. These cancel. I end up with 3x plus 18. Wait, this one goes unevenly. Oh, I apologize, kids. I fixed this apparently on the answer key. I did not fix this here. This is supposed to be a 21. 21. You'll see why in a minute. Otherwise, it went in evenly. I'm like, wait a second, I got no remainder. I know I'm supposed to have a remainder. So, x times 3 is 3x. So, plus 3. So, that's 3x. And 3 times 6 is plus 18. Now, I'm going to come through and subtract. Subtract. I end up with 3. Now, before, it always ended up being 0, right? Not in this case. Okay, in this case, I end up with a remainder. So my answer, much like my answer up here, is this, what we ended up with, plus my remainder over the divisor. So over here, my answer is 2x plus 3. Now this is a positive 3, right? So it's plus 3 over my divisor, x plus 6. You liked that. I know you did. Let's do another one. We got one last. I think this is the last problem. Oh, All right, well, last problem. Make sure I didn't. Okay, so we're going to do x. Don't know what happened there. We're going to do x minus 3 dividing into x squared plus 2x minus 5. This numerator does not factor. So if you end up in the thing where it doesn't factor, you got to do long division. X times x is x squared. So that gives me x squared minus x times negative 3 is negative 3x. We're going to subtract. So subtract, and two negatives make a positive. So this gives me 5x minus 5. So x times 5 is 5x. So 5 times x is 5x. 5 times negative 3 is negative 15. We're going to subtract. Minus. Again, two minuses make a plus. So I end up with negative 5 plus 10. These cancel. Negative 5 plus 15 is 10. So my answer, when I ask for this division problem, is x plus 5 plus 10 over x minus 3. What'd you say, Betty? You wish you could check your answer to make sure that it's correct? You're awesome. Of course you can check your answer. I can check that answer. What are you, crazy? I'm not. Let's check this. Watch this. You're going to be loving me after this. You're going to be like, Mr. Krause, you make math easy and you allow me to check my answers, which makes me a happy camper. So let's go over to our calculator real quick. Go into calculator mode, and I'm going to store any number I want into x. Don't use a normal number. I'm using like 2.4. It doesn't matter. Don't use 1. Don't use 0. Use something odd. Store it into x. Now we're going to type in the original problem. The original problem was control division. X squared plus 2x minus 5 all over x minus 3. Now you're going to get some stupid answer. Oh, this stupid answer. I can't believe I got such a stupid answer. Now we're going to check our answer. And I hope it's right. I'm crossing my fingers. All we're going to do is type in x plus 5 plus control division 10 over x minus 3. Now make sure you got it in there exactly as you wrote it. Bam! Tell me that's not cool. Huh? You get to check your answer. You can tell whether or not you're right. So there's no reason at the end of a problem like this, even though you ended up with a remainder. I know before it was easy. You always ended up with 0. You're like, yay, I ended up with 0. I got it right. And that's what we're going to talk about in class. Now you have a remainder. And you're like, maybe it's right. I don't know. I ended up with a remainder. Was I supposed to end up with a remainder? I don't know if I was supposed to end up with a remainder. But you did. And so you got like, oh, now you can check it. All right, kids, hit the subscribe button, hit the like button. I hope you enjoyed this lesson. I know I did. Goodbye.